I'm Massimo Nuvoli, I'm from Italy. I'm here to talk about something about RouterOS level 2 filtering. The last year in Milan, I do a talk about IPv4, IPv4, IPv6 filtering, also in RouterOS. Today, we do something lower, at lower level in the ISO-OSI stack. So, before the starting. So, I am owner of my company that is named Progetto Archivio. We are also operator in Italy as Dicobit, is only brand. And I would like to show you my private hobby, photo. This is mine. And then we start. Okay. Today's goal is to explain and to know more about level 2 filtering RouterOS. There is less knowledge about this feature that is spread present in the RouterOS devices. And what is changed in the last year? There is a lot of changes. And I prefer to not make a presentation about menus, a lot of examples that are quite simple but complex. So, then, just kidding. Some level 1 filtering. I do that in my security course, so I had this kind of in the presentation. This is the first one, okay? Cut here to activate firewall. There is, okay, this is level 1 firewall. But there is the version 2 that is more complex. And this is, sorry, okay, this one. Inside there is a firewall. So you must find them and then put some, I don't know. This is real. This is my customer. Then, from RouterOS 6.41, there is a big change in the configuration of the internal switch. There is no more master-slave interface because this is a little confusing. Also during the training, we have many problems with students because this master-slave is not. And the solution is to use everywhere and everything as bridge. So you have bridge, and there is inside the bridge a new function that is hardware acceleration. Nothing changed for the device, same speed, same functions, but change only the way we can do the configuration of the switch. There is also new H label on bridge port. We see that later. And this means that this kind of port is doing hardware acceleration. We must use this careful because if there is hardware acceleration enabled, the traffic doesn't go to the bridge. The traffic between ports of the bridge that are hardware accelerated is not bridged, is switched. This is the new way. Then, in L2 configuration, we have what you see. When you define interface, you have hardware acceleration. This is standard configuration, is yes with new device, but if you import old configuration from RouterOS device, or if you do an upgrade, hardware acceleration is disabled by default. You must check every time this switch because it's important for the performance of the device. Then, new in level 2 configuration, and this is very important, this is level 2 filtering related, is VLAN management at bridge level. Finally, we have a simple interface to configure VLAN management in a RouterOS device. It's very simple. It's not the oldest one of the switch. We have a new menu that is interface bridge VLAN. We have the older STP, RSTP, but we have also MSTP, that is multiple spanning tree protocol for use with VLAN. It's very important because in a more complex environment we need this kind of function. Then, one very important thing that you must think about configuration about this function, hardware acceleration, is that is configuration driven. So, if you use some feature that need to disable the hardware acceleration, the device, also if you have enabled hardware acceleration, stop to use them. So you might check, this is real time, if you change the configuration, device can disable the hardware acceleration. This is explained in the wiki. This is a limit of the implementation today. Not all functions of the bridge, filtering, VLAN are supported for all devices. So if you have a device, you must check if this function can be enabled and if this disable hardware acceleration. This is important. And this is not running time change. This is configuration change. If you enable something, the hardware acceleration goes disabled. So, just to say, if you want, this is a simple device. We have 4 ports in the switch. This is the H. We have 3 ports, sorry for the cursor, okay. We have the switch, that is the bridge that brings all interfaces. 3 ports that 2, 3, 4 are in the bridge and hardware accelerated. So if there is traffic between port 2, port 3, port 4, go to the switch, not to the bridge. It's wire speed in every device. But there is a new switch. This is the most used. If you go to the new function, VLAN, okay, you can see that there is a switch, VLAN filtering. Just click, apply, then go back to the ports, and magically, some seconds, okay, H disabled. This is configuration change, then disable hardware acceleration. It's very important after make modification to the RouterOS device, check if hardware acceleration is enabled. It's clear? Then, the switch to enable or disable hardware acceleration is hardware offload, is there, and can be enabled, disabled by each port. So you can have some port enabled, some port disabled, is not important. One important thing is that if you upgrade from previous version, then you have switch, the classical master-slave configuration. The switch is converted in bridge. As trainer during the course, I I tell to my student to do not do that. For me, it's best to convert the switch in bridge before the update of the device, because you choose what to do with the bridge or the switch. But automatic configuration and upgrade is working, so is only to be clear. Then, so the goal of the level 2 filtering, what is? Why we need to do level 2 filtering? There is a lot of complex things that we can do at level 2. And the more complex are related to the QoS, but not the QoS of MikroTik, the QoS of network level, so the management of some kind of switch that are in the packets. But I just report security performance. Both level 2 filtering can go also inside the packets, but there is a limit because the packet must be normal. Normal is a classic packet, not MPLS, IPsec. So this kind of filter can do something complex that reading the header of the packet. It's very important. Also, take in mind that with switch and with the level 2 filtering, if you use hardware acceleration, there is a limit in number of rules that you can use in hardware acceleration. If you put too much rule, hardware acceleration is even disabled, even if supported, because the hardware support of rule in the hardware is resource limited. We have 16, 8, 4 rules depending on some device, or no limit, but the smallest one have more limit. Then, this is very important. Talking at level 2 layer, we deal with MAC address. We have no IP. We have the second level of the stack, so we have only MAC address, physical address. Then MAC address, I choose to write this sentence because it's clear. Security based on MAC address is what? There is not sense to put security and MAC address in the same statement. It's wrong, because I can show that this is bridge. Okay. This is this is the MAC address of the bridge of the device. It's changed by hand. And I am not a monster. Everyone can do that. So using MAC address for filtering is possible, but not secure. Okay? Then another problem is that when you are connected physically to a network, we talk about physical connection, not wireless, the security is less secure. And also, there is a problem that in RouterOS, there is not support for the 802.1x protocol for authentication on wired connection. There is on Wi-Fi connection, not on wired connection, not supported. At level 2, we can do some nesting, but about filtering protocols, because we can choose what kind of packet to go through the filter. And I do this example, then we have some more practical section about PPOE, DHP, something about filtering kind of protocol that the customer of the network can use or can pass the firewall. So, and we can do some check without being too complex on the VLAN, on the priority, on the service VLAN, and Q that are everything is related to the header of the packet, is the third part of the packet. One good thing about RouterOS is that there is a complex but complete schema of the packet flow inside the device. So level 2 filtering is limited because we have MPLS, writing decision. This is everything, but bridging is doing here. And this is added because we can have MPLS traffic, so we can choose to have a packet that can go through the MPLS and or VPN, and so is decapsulated, and go to the interface, so is normal, but must pass 2 times in the bridge. The first time with encapsulation, the second time with no encapsulation. This is important because this explains why at hardware level we have low CPU cost because the switch is doing filtering. At bridge level we had medium CPU cost, but the same filtering level, the same check on protocol or MAC address can be done at RAW or IPv4, IPv6 firewall, and this is more CPU consuming. So doing that in hardware is right, doing that in bridge is right. We can avoid to do that in the normal firewall. In the hardware switch, I love to show that every time because in the RouterOS, in the MikroTik site, there is, for some devices, not all devices, but most devices, have the schema of the hardware, and the switch is outside the CPU and router hardware. So if you do something about filtering inside the switch, the CPU is totally offloaded of this. It's very important. Check about your device and control if you have a switch. If you have, this switch is capable to do level 2 filtering in hardware. In hardware switch, we can do more complex things. It depends on the device. Some device is simple, some device is complex. So you must check on the wiki about your device and check what is possible to do. In the small device, we can do less things. But one of the things that I say every time is that remember that hardware is limited resources. So you can do that, I say before, 16, 8, 4 rules, no more, because this is in hardware, okay? Check wiki for limits, is all documented. I can show you that. We have 9062 device here, HPHE. There is a switch menu. We can see that the chipset is QCA 8337. There is port configuration, OS configuration, VLAN configuration, and also rules. And if you go to add some rule, you can see that we have possibility to check if the switch, port, MAC address, MAC protocol, VLAN, and also do some modification. It's limited, but very powerful. This is wire speed, so very, very, very powerful. Then I had this slide this morning because there is also switch-OS devices. Most are simple, but there is also in switch-OS devices some filtering function. Just to remember that the hardware is the same. So some limitations are equal. And also check wiki for details for the device that are able to run RouterOS and switch-OS. And this is most important thing about hardware switch. You must use only one of them in the configuration, must. It's possible to use all, but it's confusing and maybe it's not working also. If you do some configuration at hardware switch level and you do also some filtering in the bridge logic with today configuration, 60, 41, and later RouterOS devices, you can do something that is not working. So my idea is to, or you configure hardware switch, or you put the configuration in the VLAN and bridge configuration, not all two. This is not obvious. Then, this is the first example to show you some interesting thing about filtering. This is simple. We do this in the chain forward. So, stepping back. Formally here. This is a packet that is not local and is go to the forward chain inside the flow. Then, just to show you, this is packet that have destination MAC address, all F. Someone can know what is this? This is DHP request. This is, someone can tell me what, okay? This is the destination port 67. This is example with the interface header 5. And this is also selection on the protocol. I check to log the request. This is protocol IP. And this is a selection about interfaces that must not be Ether 5. This is a simple configuration that I put to implement this kind of schema. We have a good DHP server, we have a client, we have this interfaces that is Ether 5, then the RouterOS bridge firewall, and here we have a bad DHP server. This is common scenario. We have a network, someone without be brain connected, put a second DHP server on the network. And this server can be contacted also by the client if you don't use this device to filter the DHP request. In this way, the client only see the good DHP server. This is the configuration, okay? Only one rule, and we do that. Quite simple, quite fast. And the only thing that you must remember is on all ports that involved in this configuration, you must disable hardware offload, because this is done at bridge level and can't be actually hardware accelerated. This is the second example. It's quite simple too. Is configuration to put an Ethernet device in this schema. We have we choose to have only PPPoE connection on 84, 83, and so we don't accept any other protocol on the port, only discover and session protocol of PPPoE. This is the configuration. We talk about chain input, because the PPPoE server is the RouterOS device. Then we go to accept the MAC protocol PPPoE discovery, and also PPPoE. And I put also a specific rule to drop in the forward chain all the other protocols. In this configuration, I used import in the interface list feature of the RouterOS that is last year new feature. And this is quite useful because you can do in the interfaces menu, interface list, you can define a list of Ethernet port and use this configuration also in bridge filtering. So if you go to the filters and you go to this, okay, interfaces, in interface list, and you can choose the interface list that you do. This is quite fast and is also useful to export and import configuration from device to device, because it's not hardware related, the configuration, but only the interface list is hardware related. If you want to, there is my talk about this kind of argument the last year in Milan. Then, the third example is about VLAN. It's more complex on the command line that quite simple in the new interface, because this is new feature. Actually, if you define a bridge and you define interface, you can do this kind of definition about private ID, and you can do also filtering on VLAN that is more simple than before, because you choose what interface is tagged, what is untagged, and what is the VLAN ID that you must use. It's very simple, because this is quite complex to do in the switch configuration and also quite complex to do in the filter configuration. This is the schema. We have one trunk interface with one untagged VLAN 1, tagged 200, 300, 400, and 3 ports that have untagged on each 4, 3, 2 VLAN. This is quite complex to do with the whole configuration. Now, the only thing that you must do is what I do in the start of the presentation. So enable VLAN filtering in the bridge. This in some device, not all device, disable hardware acceleration. Okay? And if you do that, VLAN management is done by the bridge and following the rule that you put in the configuration. I can show you that. This is new configuration. So this is dynamically added by the configuration manager of the RouterOS. Then we can see this is quite simple. I choose the bridge, the VLAN ID. I tell to RouterOS, this is tagged, this is untagged. Simple. I can tell you that before that is very complex. So it's step ahead. Then So if you want to access VLAN 200 packets on the bridge from RouterOS, you must add also bridge itself on the filtering. So this is new. This is the only complex thing that if you want to have the RouterOS device access the VLAN packet inside, you must add also the bridge interface to the filtering. This is the only complex thing that I need to do, if needed. Then more complex example. This is also level 2 filtering. WMM packets and VLAN tagged packets that have some kind of classification. This is only example. And take priority, and all other traffic take no priority. This is done with interface list. And then we use Mangle, that is IP level configuration, not level 2 level configuration. But it's quite simple. We define a list. We see before where is interface lists and so. We define a bridge filter that classify the priority. If priority is 0, set priority, new priority is 7. Then we had a Mangle configuration that is more complex, but is not so difficult. We mark packet in the chain forward with priority 7, new packet marked priority 7, pass through. And then we do QoS, MikroTik, RouterOS QoS, changing and doing regulation about the speed. And this is the simple queue that take priority and limit, max limit, and check packet mark priority 7. This is quite simple, but without the configuration in the bridge, we can not check the ingress priority. That is very important. This is only to show you some feature about filtering. Then some question? It's okay for me. It's not so difficult. Oh, no problem. Thank you all.
Hello. I indeed have a question, but
Not for okay.
Don't worry. The new switching code in MikroTik, what do you think? Why it is now capable of VLAN? MikroTik inside is a Linux kernel, and the old switching code in the Linux kernel also is not capable of VLAN. How do you think this is implemented in the new MikroTik?
I think there is this challenge because actually kernel of the device
do you think
it's clear that they are changing the kernel.
okay.
So this is not.
I was thinking it's like that has late reported, but it's better to know.